So welcome back. We're going to graph one more linear equation using the strategy of solving for y, and we're going to also use that three solution method along with this. So we're going to have this equation 5x minus 2y is equal to 10. Again, typically when I see this, if I'm just trying to graph it, this fits perfectly defining the x and y intercepts. But later on, it's a good idea to learn how to also solve for y, so we're also going to kind of start modeling that strategy as well. So solving for y, our first thing is to zero pair that x term. So since I see a 5x there, that's telling me to use a negative 5x to zero that out, but also got to put a negative 5x on the other side. So the 5x, negative 5x will zero out. I have a negative 2y that comes down, and I have now a negative 5x and a 10. So I have a negative 5x and a 10 on that side of the equation. Now to get y by itself, I need to get rid of this negative 2, so I'm going to divide by negative 2, since that was multiplication. Again, solving, we always think backwards. So if I see multiplication, we're using that division. So I also got to divide this side by negative 2, so I got to divide each term over here by negative 2. So the negatives will divide out. I have y is equal to then. And we know that a negative and a negative makes a positive, so I'm going to just change it to 5 halves x. And then 10 divided by negative 2, that's going to make that a negative 5. So I'm going to put a minus 5 there. So I've achieved my goal of solving for y. Now I want to make my table. So again, to make my table, let's pick easy values. 0 is always good. Put 0 in. We have y equals 5 halves times 0 minus 5. So 5 halves times 0, 0 is out. So negative 5 would be my solution. So 0 went in, I came out with a corresponding y value of negative 5, so that's a solution. Now my next term though, since my 2 is my denominator, it's a good idea to use a 2 so to divide out. So I have y equals then 5 halves times 2 minus 5. 2's divide out, 5 minus 5 is going to give me then, looks like that's going to give me 0. So 2, 0 is the solution. And then also I can use a negative 2 to divide that out with. So 5 halves times a negative 2 minus 5. So 2 goes to the negative 2, that's going to make that a negative 1. 5 times negative 1 is, so negative 5 and a negative 5. That's going to make then a negative 10. So I'm going to have then 2 kicked out, nope, a negative 2 kicked out, a negative 10. I don't think I can fit that on my scale since I'm only going by eighths, so I may want to choose a different number besides a negative 2. I'm going to go ahead and just choose a, since I got a 2 here, I can also use a 4. Let's see where the 4 takes me. 5 halves times 4 minus 5. So 2 is going to go into 4 twice. 5 times 2 is 10. 10 minus 5, that's going to be a 5. So that's not so bad. I can fit that one on my graph. So 4, 5 would be actually a fourth solution. So 4, 5 would be another one. So I found 3 solutions, but again, I'd have to adjust my graph. So I took a chance. I did find another solution that fit on my graph. So let's see what I have here. So graphing the solution, 0, negative 5 would be located at this spot. 2, 0 would be located at this spot. Negative 2, 10, negative 2, 10 is going to be up here somewhere. I'm sorry, negative 2, negative 10. That would be down here somewhere. Negative 2, negative 10 would be approximately about there off the graph a little bit. And 4, 5 fits nicely on my graph. 4, 5 would be here. So using my straight edge, I should be able to line up those points, and I should be able to draw a line through those points. And you kind of see I probably should have went down even further. So more like down there somewhere. So negative 2, negative 10 would be probably more like there then. Okay? So I've achieved my goal though. I've solved for y. I found 3 solutions. I put them in a table. and I graphed them, and I drew my line through those points. And that's what it's all about when we talk about graphing linear equations. So hopefully you found that useful, and I believe that concludes those lessons, and we're going to move into that other topic we kind of were hinting to, this concept of this guy right here, this 5/2. Notice if I go from this point to this point, notice that the ratio is 1, 2, 3, 4, 5, 1, 2. If I go from here to here, notice it goes 1, 2, 3, 4, 5 over 2, 1, 2. So that number has some power behind it. And we're going to talk a little bit more about this, what we call the coefficient x. Is going to have a special name that we'll get into in the next lesson. So stay tuned for that.